6. Mr. Lewis, what are we up to? I kind of wasn't paying attention.
We're going to continue with the geometric model.
All right, I'm good for that.
We're going to do a couple of sample problems and play with our calculator. It'll be a fun little time.
All right.
Okay.
That's what I was going to do anyway.
All right. So here's problem number 1.
We're on number 2 already?
Yeah. Well, these are taken from a worksheet. I didn't change the number.
All right.
All right. Suppose the computer chip manufacturer rejects 3% of the chips produced because they fail pre-sale testing. What is the probability that the 7th chip you test is the first bad one?
Let's do it by hand, and let's do it by calculator. Does that sound okay?
Yeah.
So geometric model is not so bad to do by hand.
Nope.
So we want the 7th one to be the first success?
Right. So I had...
We got to fail 6 times, right?
Well, we want the 7th one to be the first bad one. So we had 97 successes, and then now a failure.
But in probability, you got to think success is whatever we're looking for.
That is true.
Yeah. So this would be little q, probability of failure.
Yes.
Of getting what we don't want.
Right. This is what we want.
And little p is what? But it's 0.03.
Oh, I'm sorry. Ooh, 0.03.
All right.
My stats students will tell you it has not been my morning.
That's all right. It takes a little while to get going here. 0.03. All right, I get 0.0249, so about 2.5% chance.
Okay.
So when it's outright just calculating the probability, like what's the probability that we get the first thing we're looking for the 7th time, not so hard to do. Now, there's a key on the calculator.
There is.
So if you go under second distributions and all the way down, it's option E. E and F relate to geometric model.
Okay.
And it's called Geomet PDF.
So then we do geometric.
So just Geomet like that.
Okay.
PDF. It means probability density function. Okay.
Right.
And then if you have a newer calculator, it'll ask for the p-value. That's the probability of what you're looking for. So it'd be 0.03.
P would be 0.03.
Then
if you don't have a newer calculator, you just put in 0.03.
Yeah, it's a real pain to remember. And then it asks you for the x value. That's the trial you're looking for.
Mm-hmm. So here would be the 7th trial.
7th trial. Very good. And then you just hit enter or have it pasted, and you get the same thing, 0.025.
Mm-hmm.
So it's good to be able to do it by hand. But when we get to ones where it's less than or equal to, calculator is going to be very helpful.
Yes.
All right. Okay, we did 2 ways. Next.
Okay.
So assume that 25% of people are left-handed. Oh, my middle daughter is. All right. If we select 10 people at random, find the probability that the first lefty is the 3rd or the 5th person chosen. That's a union.
Yes, it is.
And these are disjoint events.
These are. So we would just add them together.
Right. So we're gonna do it calculator style.
Okay. Let's do it.
How about that?
All right. That works.
What do you want to do, Mr. Lewis?
I mean, I'm good either way.
All right. So let's write the command for both. So Geomet PDF. And again, go to the distributions where the normal curve was and go way down to the bottom of the list.
0.25. So here we want to select it on the 3rd try.
All right. And it's 0.14. So 14% chance.
Okay.
Or on the 5th. So we just have to do the same thing. And change it to 5th trial. And it's 0.079.
Wow.
If you add those, you get about 0.219.
I'm sorry. Oh, 0.079. That's why.
Yeah,
that's why I screwed it up. Okay, hang on. We're gonna. There's no eraser on this. 0.07.
It turns out for every geometric problem, the longer the wait, the lower the probability.
Yeah.
It only goes down.
Works that same way with the binomial pretty much as well. Well, not all the time. It kind of like humps a little.
Yeah, it looks like a normal curve most of the time.
But
we'll get to that. Don't worry about that right now. All right, B. So when you add them, you get 0.219. Yeah, so we just had to do 2 Geomet PDFs.
197.
Okay, next. Right, this is slightly different. So suppose that a certain population, 6% of people are colorblind. A researcher selects people at random from this population. What's the probability that the first colorblind person will be found among the first 7 people checked?
Right.
So it could be the first person,
Mm-hmm.
or the second, or third, or fourth, fifth, sixth, or seventh.
Mm-hmm.
So could you put, what they want is the probability that x is less than or equal to 7. So remember, x is how many trials it takes to get a colorblind person.
Yes.
And we're adding it up. Probably that's the first, probably that's the second, this will probably is the third.
Mm-hmm.
All right, now this is a real pain. We'd have to do 7 Geomet PDFs on our calculator and add them up.
Mm-hmm.
But there's one command that does this all at once.
Yes, it does.
It is Geomet CDF.
Okay.
That's the second command on the calculator. The C is for cumulative. And the first thing you put is the probability, which is 0.06. And the second thing is you put the number of trials, 7. But what it does is add up the probability 1 through 7. So maybe draw a little arrow to the C. And so that's the difference. When you want just one value, PDF. We want less than or equal to a value, CDF,
yes.
Cumulative. All right, so we just got to enter it. So I'll go back to the distribution menu. That's the very last one under distributions. 0.06, x value is 7, and we get 0.35. Actually, we get 0.3515224058, which is closest to B. So it's just recognizing this. When it's less than or equal to a value, cumulative CDF.
Mm-hmm.
Okay. Let's get used to those 2 commands. All right, Mr. Lewis, what do we got?
All right, so the last one, we have suppose that 19% of students at one college have high blood pressure. If we keep picking students at random from this college, how many students do we expect to test before finding one with high blood pressure? So this is an expected value problem.
And why is it a geometric model?
Because we want it to end when we find somebody with high blood pressure.
Yeah, waiting for success. So
Right.
if it's a problem where you're waiting for something to happen, geometric model.
Mm-hmm.
Okay.
So our expected value of x would be 1 over the probability.
Of success, good.
Right. So in this one, it would just be 1 over 0.19. And
This was the easiest problem.
it really was.
5.26.
So about 5 kids, 5, 6 kids would be our, because I don't really know why they kept the decimal there, because I mean, you can't really have 0.2 of a kid.
Yeah, but
you get,
that's the class thing. But remember, this is an average.
I know.
So that's why it's 0.26. Okay, believe it or not, that's it.
I know. Time just flies.
So we got 3 different types of problems here.
Yeah, so we gave you a kind of one of each. So here we have a basketball player that's made 70% of his foul shots, assuming that the shots are independent. Find the probability that in tonight's game he makes his first basket on his 6th shot. All right.
Right.
Which, by the way, the answer probably will not be in this.
Oh yeah, cross those out. So it's not going to be one of those. We changed the problem a little bit.
We did.
Yeah, so put your own answer.
Yes.
Okay.
A laboratory worker finds that 1.4% of his blood samples tested positive for the HIV virus. On average, how many blood samples should he expect to test before finding one that tests positive for the HIV virus?
I swear it's one of those.
Yes, this one, it will be right.
I don't know which one.
So, blood samples expecting to test, that's an expected value. Okay, and then suppose that in one city, 72% of the cars parked at meters still have time remaining on the meter. How many cars should a meter maid expect to check before finding one? Oh, and that was another, I guess they got a break on the Mustang thing.
Okay. All right.
Yeah, sorry.
We gave up on the multiple choice there.
Yeah.